So let's explain a couple of general concepts. So first of all, you would want to know where this drug goes. So let's say you are conducting a study on a specific drug and you want to know where a drug goes. Is it just bound to the blood? Does it actually distribute itself in other parts of the body? So does it actually store itself in fat cells or anything like this? Or does it just remain confined to the blood itself? You would know this by knowing the volume of distribution, where the drug is actually distributed. So if the concentration is high as you would expect it to be, you know that it is just confined to the blood. If it's way too low or the volume is way too high, you would know that it actually goes somewhere else, maybe other organs, or is distributed into fat cells. So how do you find out the volume of distribution? You would find out a volume using the mass or the amount, and you would find it out using also the concentration. And the equation for any concentration is equal the mass or the amount divided by the volume. And the volume here is equal to the volume of distribution, and the mass is the amount of drug administered, the dose administered. And the concentration is actually the plasma drug concentration. But which plasma drug concentration? The drug concentration at the time when this dose was administered. So it would be the initial plasma concentration. So let's rearrange this here. So this divided this times this divided this. So you would have the volume of distribution equal to the dose administered over the initial plasma concentration. So now you know where the drug actually goes. If you find the volume of distribution way too high, this means that this drug goes elsewhere. It doesn't just confine itself to the blood. So the second thing you would want to know is the clearance. The clearance, especially the total body clearance, which is the total amount of drug cleared by the body, so be it by elimination or by metabolism. And this is the amount of plasma in theory, or at least in definition, it is the amount of plasma cleared of a drug in a specific unit of time. So let's say in a minute, it is the amount cleared in a minute. It is the volume of blood cleared of a drug in a given minute, in 1 minute. And you could calculate it using this definition. It is the volume of the blood or the volume of plasma cleared of a drug per unit time. And NANI? And you should learn here that the unit of K, or at least in the first order, the unit of K is equal to 1 over time. If we were talking about clearance, we are talking about the elimination rate constant, which is the K, or in this case, the KE. And the unit for the K, or the unit for the elimination rate constant, is 1 over time, or time power -1. So you could replace this part here with K. So clearance is equal to the elimination rate constant multiplied by the volume of distribution. So this unit will come in handy, because if you wanted to know the rate of elimination of a specific drug, if it follows the zero order, you could just find it because, well, K is the unit of elimination rate constant in this condition is just, well, amount eliminated over time, milligrams per hour. While in the first order K, the unit of K is 1 over time. While the unit of K is 1 over time. So time is, you would want the amount, or the amount cleared per unit time, which is, you could just remove amount and insert dose. The dosage gotten rid of, or the dosage eliminated, the amount eliminated per given time, which is equal to K multiplied by the dose. And this is important because if you wanted to know the rate at which a drug is eliminated, you could calculate it with this very simple equation. This is the end of this part of this video. Hope you liked it. If you did, please thumbs up, subscribe, hit the bell icon, and also don't forget to go to our website where you can find some handouts that should be good. Thank you for watching, and see you next time.